Welcome to Tectonic Nights channel. In today's video, we'll be solving LeetCode string problems using these built-in methods in Rust. First problem is reverse vowels in a string. We are given a string and we need to reverse only the vowels in a string. For example, let's say here's the string. We reverse the vowels by swapping I with A and E with E. We can use two-pointer technique here to swap the vowels efficiently. Left pointer starts at the beginning of the string, which is index 0, and right pointer starts at the end of the string, that is last index. First we increment the left pointer until it points to a vowel. Next we decrement the right pointer until it points to a vowel. We swap the vowels at the left and right pointers and repeat this process until the left pointer is no longer less than the right pointer. Now let's dive into the coding section. First we convert the string into a vector of characters using characters iterator. A string in Rust is a collection of UTF-8 encoded characters, and it's not directly a collection of character elements. Instead, string is a sequence of bytes that need to be interpreted as individual characters. Rust provides convenient iterator characters method, which is used to iterate over the characters in the string. We use collect method to gather those individual characters into a collection. The collect method is a very flexible method in Rust that can transform an iterator into a variety of collections. In this case, it's used to collect the characters into a vector of characters. Next, we define a separate vector to store the vowels in the string. We define two mutable pointers left and right, initialized to 0 and length of string -1. We start the outer loop with condition left less than right. Then the first inner loop ensures that the left pointer skips over any non-vowel characters. It moves the left pointer to the first vowel in the string. Similarly, the second inner loop ensures that the right pointer skips over non-vowel characters, moving it to the last vowel in the string. Here's the result in each iteration. Once both pointers are positioned at vowels, we swap them using swap method and update the pointers. Since both left and right are of type usize and unsigned integer, decrementing right pointer at the start of the string could cause an error. To prevent this, we include a condition left less than right before updating the pointers. Next problem is merge strings alternately. We need to build a string by merging characters from the given two strings in alternate fashion, and if the string is longer, additional letters are appended. First, let's iterate through both the strings simultaneously. We can use chars method to obtain an iterator over the characters of each string. We can use zip method, which combines two iterators into a tuple of characters. Here's the result of printing the tuple in a for loop. We start with an empty string, and inside this for loop, we append characters using push method from both strings alternately. Here's the result string. We are yet to check if either string has leftover characters. If the word 1 is longer, we append the remaining characters, which is a slice from word 1, using push string method. Push string method in Rust needs a borrowed slice rather than the ownership of the string itself. So we pass a borrowed slice to this method using ampersand. And the start index of the slice is length of word 2. Similarly, if word 2 is longer, we append the remaining characters from the word 2 to the result. Another approach to solving this problem is as follows. The next method of an iterator returns the next element. If the element exists, it returns sum of element. We can use an if condition to check whether the next element is available. We assign the result of chars.next to a variable using let, which will either be sum of character or none, depending on whether a character exists. Now let's apply this approach to iterate through both the words. We can determine the maximum length of the two words using the max method. Next, we loop until we reach the maximum length and check whether the next character from either word exists. If it does, we append the character to the result string. Stay tuned for part 2 coming next week. Thanks for watching and we'll see you then.